Why do some egg incubators have two upside-down water bottles? The upside-down design is a smart use of gravity. When placed into the holder, gravity immediately pulls some water out of the bottle. As soon as the water reaches the bottle opening, the opening becomes sealed by the water. Air can no longer enter the bottle, and a partial vacuum forms inside the bottle. The vacuum balances gravity. The flow stops. As the incubator stays warm, a small amount of water in the reservoir slowly evaporates, causing the water level to drop slightly. For just an instant, a tiny air bubble slips into the bottle. That single bubble allows only a small amount of water to flow into the reservoir. Then the bottle quickly seals itself again. The vacuum reforms. The flow stops. Then the entire cycle repeats. No pumps, no valves, no sensors. Just gravity, air pressure, and a simple law of physics keeping the water level almost perfectly constant. A stable water level creates a stable evaporation surface and, therefore, stable humidity, which is crucial for a successful hatch. Now, why use two bottles? Most people assume these two upside-down bottles are simply there to hold more water. They're not. In fact, one of them isn't even used until the final days before hatching. The purpose of the two-bottle design is to create two different humidity levels at different stages of incubation. Usually, poultry incubation consists of two stages: the incubation stage and the hatching stage, or the early stage and the final stage. During the early stage of incubation, an embryo needs warmth and the right amount of moisture to develop normally. At the same time, it also needs to lose water at exactly the right rate. Slowly enough to avoid dehydration, yet fast enough to develop a healthy air cell. Although an eggshell feels hard and solid, under a microscope, it's covered with thousands of tiny pores. These microscopic pores allow oxygen to enter the egg, carbon dioxide to leave, and a small amount of water vapor to slowly escape throughout incubation. As water leaves the egg, an air cell gradually forms at the large end of the shell. See this empty space? That's the air cell. It has a critical job. Just before hatching, the chick breaks through the inner membrane into the air cell and takes its very first breath. Only then does it begin pecking its way through the shell. If the air cell is too small, the chick will not be able to hatch. And what causes the air cell to be too small? Too much humidity causes too little water loss, resulting in an air cell that's too small. But on the other hand, too little humidity will lead to embryo dehydration, which is equally fatal. So, what's the ideal humidity level? For most chicks, during the first 18 days of incubation, the ideal humidity is usually around 55 to 60% relative humidity. This allows the egg to lose moisture at the proper rate, producing a healthy air cell without dehydrating the embryo. After the air cell has formed, incubation enters its final stage, also known as the hatching stage, and the chick's needs change completely. It needs to peck through and break the shell, for which higher humidity is critical. You might have heard that higher humidity softens the shell so the chick can peck through. That's a common misconception. Instead, it keeps the inner shell membranes moist and flexible. If these membranes dry out, they can shrink tightly around the chick, almost like plastic wrap. The chick may still have enough strength to pip the shell, but not enough room to rotate, zip around the egg, and hatch successfully. By keeping those membranes from drying out, higher humidity gives the chick a much better chance of completing the hatch on its own. So, what's the ideal humidity during the final stage of incubation? It is usually around 65 to 75% relative humidity. Now, let's recap. Early on, the goal is carefully controlled moisture loss, keeping the embryo properly hydrated while allowing a healthy air cell to develop. Later, the goal shifts to keeping the inner shell membranes moist and flexible so the chick can hatch safely. Now, you've probably understood what the upside-down self-regulating bottles really do. They make two-stage humidity management remarkably simple by maintaining two different water surface areas for evaporation. That's why we use this system across most of our Z-Miro classic incubators. It's not simply a design choice. It's a genuine effort to give life exactly what it needs at exactly the right time.